function y is equal to the secant x and y is equal to cosecant x. Graph a secant function, graph two full periods of y minus 3 secant x over 2 for minus pi and is less than x and x is less than 5 pi. So first of all, let's see here. We already know the secant. So this function here, let me take a pen here. And we already know this secant is related with a cosine. So first of all, let's find the function y is equal to the minus 3 cosine x divided by 2. And if we are analyzing this function, the amplitude is absolute value of 3. Minus 3, which is 3. So the amplitude is 3. And 3, let's say here is a 3 and here is a minus 3. Okay. So now we want to find the period. Okay. To find the period here, we have in this case, this is a b here. So this function in general form is the formula y is equal to the a cosine b of x. So that's what we have here. And the period is 2 pi divided by b for the cosine x and for the sine x. In this case here, b is 1 over 2. So b is 1 over 2. If we are taking x here, we can write 1 over 2. So in this case is 2 pi divided by 1 and 2, and everything here is 4 pi. So the period is 4 pi. And now we are going to sketch the graph of the function cosine x. But we already know here, because we have a negative, and this function is going to be reflection of our x-axis with a reference to the parent function a cosine bx. So it means here is going. But now, because we have a period of 4 pi, we want here to find the critical points where it's going to intercept the graph of the function. And because we have a 4 pi, and if we are looking here to divide in 4 the same spaces, and 4 pi divided by 4 is going to be pi. It means that everything here is 0, let's say, pi, 2 pi, 3 pi, and 4 pi. So this interval 4 pi, we are divided in 4 symmetrical sides. So 1, 2, 3, 4 pi, and here is a 5 pi. And here is a minus pi. Okay, so we are looking to restrict this domain, what is given from minus pi to 5 pi. And this is a pi, 2 pi, 3 pi, 4 pi, and this one is 5 pi. But now, because the function we already know, this function has to go from 0, and it intersects at this point here, then reaches to this point here up, then go to this point here, and in the end goes to this point. Okay, so this is how it goes. And the function is going to look something similar in this form. So let me graph the function. It goes from minus 3, goes to pi here, goes to this point here, and to this point. And now reaches to this point here. But here is one period. Okay, but we have to go up to 5 pi. 5 pi goes up to here. And of course, this function has to go something like this side, and it can continue forever, this period of the function, because we already know the cosine function is a periodic function. It goes from minus infinity to infinity, but we want to find out here in 2 full periods, we want to find this secant, because we are looking for this function, so do not forget. And to find the secant has asymptotes. The asymptotes of secants are whenever we have those the points of x-interception in the cosine x. And x-interception happens to be, so x is going to be n pi. So n is element, can be any integer. For example, if it's a 0, just let me see here, in 0 doesn't go, pi, 3 pi, but here it can go, just let me rearrange a little bit, because the minus pi, pi, 3 pi, 5 pi, it means 2n minus 1 pi goes. So if n is equal with a 0, goes minus 1 is minus pi. If n is equal with 1, 2 times 1 is 2 minus 1 is a pi. Okay, if n is a 2, 2 times 2, 4 minus 1 is 3 pi, etc. But now the asymptotes is going to go everywhere. This formula here is going to produce the asymptotes of this function. And in this case here, the asymptote is going to be in this point, as I said, whenever we have an intersection. So here is one asymptote. The other asymptote, so let me take a different color because I think it's not, we cannot see very well. So here is the one asymptote. The other asymptote is here. Okay, so x is equal with a pi. So here is one asymptote. Another asymptote, x is equal with a minus pi. The other one asymptote is x is equal with a 3 pi. So x is equal with a 3 pi. So this asymptote here. And the other asymptote is x is equal with a 5 pi. So x is equal with a 5 pi. Those are the vertical asymptotes of the function y is equal with a minus 3 secant x divided by 2. And now, just let me see here, let me take this yellow, maybe it's a better color. And now I want to sketch the graph of the function minus 3 secant x over 2. This function here is going to have, for example, in this point here, whenever is a minimum from this point starts and goes down. So this graph here is a secant. Then the other point, whenever is maximum here, is going and up. And of course, the end point of the secant function are going very close to the asymptote, the end behavior. And the other point you see is here, and it's headed down. So this is the secant. So this is a y is equal with a minus 3 secant of x divided by 2. So those yellow graphs. This is the graph. If we are looking for the domain here, the domain is from minus infinity to infinity, except x should be different from 2n minus 1 pi, 2n minus 1 pi. So whenever those asymptotes are not included in the domain. If you're looking for the range is a little bit tricky. Is from minus infinity to minus 3. Here is a minus 3. Minus 3 is going to be the minimum of the function cosine x. But up to this point here, minus 3, and it includes a minus 3. And union is going to go now from 3, from this point 3 here, to infinity. So it includes the point 3 to infinity. So this is going to be the range.